All right, today we're looking at locus of rays, specifically between two rays. There are two versions between theta 1 and theta 2, arc z is between theta 1 and theta 2, and arc z minus z1 between theta 1 and theta 2. Now, there's variations in this too. There could be equal to here, there could be equal to here, so there's four versions of this, and there's 4 versions of this. So there could be 8 versions, but I'm just looking at these two specific 2 versions of the 8 versions. For example, you have negative pi on 3 is less than arc z is less than pi on 4, and I'll make it equal to in this case for this one. Now, that means that arc z is just a ray from the origin to z. So you start with that Eigen diagram. You start from origin. Negative pi on 3, I believe, is 60 degrees, which is somewhere there. And it's dotted line because of not equal to. And then the other guy is 45 degrees, but it's equal to because it's solid line. So solid line is equal to. Dotted line is not equal to over here. And then it's just between the angle between there. So you have the region bounded by that. So if that goes on forever, and there's a region there. So this is basically pi on 4. So is that. And this is basically pi on 3, the size of it. But of course, that's enough. And that's the region for that one. An example of the other version, for example, let's say we'll make it positive this time. So pi on 4 is less than or equal to arc z minus 1 plus 4i. And it's less than or equal to, let's say, 2 pi on 3, let's say. The trick is to find out what z1 is. So you have to express this as z minus z1, and that is minus 1 minus 4i. So z1 in this case is actually 1 minus 4i, and that's the trick. So this is not in the form of z minus z1. You have to find out where z1 is. Very important, because the definition of z minus z1 is a vector from z1 to z, and so you have to start from, in this case, 1 minus 4. So 1 minus 4 is here. It's dotted. It's not colored in because arc of 0 is not defined when you have it at 1 minus 4. And the angle is 45 degrees, which is a solid line in this case. So 45 degrees to the horizontal looks like that. And 2 pi on 3, I think it's 120. 120 looks something like this. All right. And then it's just basically the shaded region between the two. And that's basically so this is pi on 4, and this is pi on 3, because it's 2 pi on 3, the whole thing up to there. And that's basically your locus of between two rays. And that's basically that. And that's where I want. So, and it's solid line in this case is equal to here. And that's where I stop.